In problem 2.1 of kaleidoscopes, hubcaps, and mirrors, question E, we're given this image and the line of reflection. And the first question we're asked is, does this image, DEF, have reflection symmetry over that line? Now it's kind of challenging with a mirror to see it if I use that line as a line of reflection, because part of the image disappears because I'm covering it with the mirror. So you can't see this part that sticks out. And so to see the reflection of all of it is difficult. But you can see that at least the part that I am given does have reflection symmetry over that line. So the image does have reflection symmetry. The question really is, how could you draw the reflected image of this? And so to do this, I'm going to use some tools here this time, just to make sure that I'm using right angles. So what I need is a line that goes from D at 90 degrees. It has to be a right angle or perpendicular line from D to the line of reflection. So I'm going to put in a line there. And I'm going to do the same with F. And I'm also going to do the same with E. All I'm trying to do is make sure that my line that I draw is perpendicular to, or at a 90-degree angle to, the line of reflection. So right here, and the angle ruler gets in the way, so I'm going to finish it with this. So there's a line, and then the last line I'm going to go ahead and use my ruler because I think I can make it straight. Now E is interesting because I'm going to go the opposite direction. I'm going to start at point E and go toward the line of reflection. Opposite direction the other two are. And I want to note that distance on my ruler here is 1.2 centimeters. So if I go out 1.2 centimeters the other way, and again making sure that I have a perpendicular line, 1.2 centimeters takes me to that point right there. And that point is going to be my E prime in the new image. You can see that the E prime is actually inside the original image. And when I go to copy D, I need to find this distance, which looks like it's 4.3 centimeters from the line of reflection. And so on the other side of that, I'm going to go out 4.3 centimeters, which, in order to make sure I keep this as a straight line, if I take 4.3 plus another 4.3, that's 8.6. So I'm going to go out to 8.6 and then go back in to there. And so that point, if that's 4.3 centimeters, and 4.3 is 8.6 to that point. So that's my D prime. And then down to the bottom, find the distance from F to the line of reflection is 3.9 centimeters. So 3.9 and another 3.9. So another be 7.8 centimeters. So I go from there, 7.8, back, and that. So there's my distance of 3.9 centimeters, distance of 3.9 centimeters, and there's my original position. Let me put in the lengths of these parts here. Since we did that earlier, it was said 1.2 centimeters and 1.2 centimeters on the other side. And so same distance on both sides. So every one of my spots, my original spots, is lined up with the original, the prime, the new spot, and its original new spot, and its original. These two are flipped because it's flipped around the line. In a sense, it's almost like it's on a stick and it's rotated around the stick, like you spin it. And now I can connect the new points with each other and make hopefully a reflected triangle. And again, the idea is if I know the distance each point is from the original line of reflection, and so now you can see D and D prime reflected across, E and E prime reflected the opposite direction, but it's still reflection again, as if this line was a post and I took the image and literally reflected it around that point so that everything flips to the opposite of where it is. E is over here, so it flips over to there. D is over here, so it flips over to D prime. F is over here, so it flips over to F prime. And so now we have, and they're all the same distance from the line of reflection, so in the end we have a reflected image across. And now it does get interesting when we put the mirror up to this, because now you can actually see the entire image reflected both directions. So once we put the reflected image in, then it completes the image, and you can see the full reflection both directions, how E prime ends up on the opposite side of the line as E, just like the others do, even though they're on the opposite sides. So reflections can happen in ways that maybe we didn't expect when an image actually crosses the line of reflection. We can take the line of reflection and do that, and in a sense it's like it's spinning in place. So we take it and flip it. It still flips about that line of reflection. And that's how we can sort of visualize. If I could really literally pick this piece of paper up and flip it over that line, and that image appears flipped as a result of that. And so that's what we're doing. And the final image has reflection symmetry compared to the original image, and so we've made what we were asked to do for question E.